We're here today with David Wicker because we have an ISA conference in Calgary that we're going to next week. And David's going to be giving us a presentation.
Two presentations.
Two
actually.
presentations. Yeah. Oh, shit.
First off, David, what is ISA? Well, we are covering a wide range of topics here. So, first off, help me with that.
International Society of Automation, I believe.
Oh, nice.
Okay. Did they write standards for some of these?
Yes,
industries?
they do. A lot of the automation standards we use in the industry are written by them.
Okay, but then also there's regular meetings, presentations on technology. I mean, what's the primary purpose? Is it for the maintaining of the standards for ISA in general?
Yes, this conference is different. This is part of their big energy show that they do once a year. So they get together the owner operators and service providers, vendors, and do a big show. So this is not focused on just standards. It's just...
You've been to this one before, though, right?
No, this is the first time we're going to this one.
Oh, nice.
You went to a local meeting in Calgary.
Yeah, I was a speaker at a tech talk they did, I think, last October in Calgary.
And that was so good that you were invited to come to the big show.
That was my understanding, yeah.
Okay. And so we expect system integrators to be there?
Yes.
Owner operators to be there who are running the plants? Vendors? Like your Rockwell, Honeywell, Yokogawa type folks?
Yeah, I haven't seen the full list, but I think all of the above.
Okay. And then we'll be there providing some technical discussions. You're giving a topic, two topics, I guess, right?
Yes, there's one because we're exhibiting focused on automating testing through test drive and loop drive, specifically our products. So that's obviously a commercial presentation. And I'm giving an educational presentation on using AI in the automation workflow, kind of the efficiency gains you can get, but then also dangers and how to mitigate those.
Ooh, that one sounds interesting.
Okay, so I think we need to dig into those a little bit. But first, a little introduction. So we've done 22 of these, 21, 22 of these podcasts. A lot of them have been focused on sort of the engineering project side, meaning the P&ID's 3D model, handover, all that type of stuff. But we do have an intentional focus also at looking a little bit deeper into the control system side. And we really haven't dove into that in terms of how does a control system get designed and built? How does a safety system complement that? How does all that interact out in the field for commissioning and startup and actually running the facility? A lot of our focus has been on the drawings and the data that supports the plan. But your expertise is primarily in that control and safety system space. Is that correct?
Yep.
Okay. So how did you, yeah, that's a good, thorough answer.
Yep.
How did you, how did you get to this point? Like, what was your career path to get you to the point where you're an esteemed speaker at an ISA show?
Sure. Yeah, I've been in the industry about 22 years now. The first half of my career was focused almost solely on safety instrumented systems. So doing the design, configuration, testing, commissioning of those systems across many facilities around the world. So I got a lot of experience doing safety instrumented systems and the best practices for programming them. Work just solely as really a system integrator for that first half of my career. And then after we created ProLytX, focus has shifted a lot to building tools and technologies that can help the industry. System integrators, yes, but with a big focus as well on owner operators and how they can improve their processes, be more efficient, save time and money on projects, yes, but then also just on the run and maintenance and reliability as well.
Okay, so when you say system integrator, you mean generally an engineering team or a company that does programming to support a facility, like builds the graphics, builds the logic, goes out, starts it up, tests it, right? That's the definition there for the folks online. Like the system integrator there is particularly about taking the documentation that's supposed to govern the way that a system's going to be built and then bringing it to life, right?
Exactly. Yeah. And the owner operators, they have some folks that do that, but their focus is more on the maintenance and running of those systems day to day. So they'll make changes, they'll manage those changes. And the standards cover all of that. But my focus historically has been on the project execution, putting in new systems, either greenfield or brownfield. But now with ProLytX, the heavy focus, it's almost shifted more towards the existing commission systems that are on the run and how to make those more efficient as well.
Mm-hmm. And when you talk about logic, so in the industry, there's generally like a graphics team that builds this operator screens, right? And there's like a network communication team that makes sure that everything's connected. And then there's a logic team that builds the control schemes and everything behind the scenes, right?
Mhm.
So some of your programming has been as simple as like text based, like actually like DOS based, like if then programming statements. Is that right? Like in the old Triconic stuff? And even up till then, like,
Programming of the PLCs,
Yeah.
yeah. But most that's part of it. Usually, you use that type of syntax for like setting set points or mode changes, things like that. Most of at least the safety instrumented systems are programmed with either relay ladder logic or function block is more common these days.
mhm.
And
Yeah,
you're
that's what I was.
giving a presentation on how to do that with AI.
No, we have tried that more on the analysis side
Okay.
with AI, and that's a little sketchy. So AI is really great at some things, but understanding a complete PLC program it still is lacking. So yes,
Interesting.
yeah.
Well, what is that? So why would someone need to understand that program?
Well, for a big part of what we do with ProLytX is testing systems, right? We've tested hundreds of systems over the last 10 years. So we're always looking for better ways to get an understanding of how a system is programmed, how it works, ultimately to see if it meets the requirements of the design documents. So AI is very interesting since you bring that up, because maybe AI could analyze a program and analyze the design documents and tell us if there's discrepancies. So that's part of what we've been exploring to see if it's capable of understanding both the design documents and the program to an extent that it can do some tests for us. It's nowhere near replacing like automated tests that we're writing and running on these systems, but we're looking to get whatever insights we can out of these systems.
So what are your two presentations again?
The commercial one on test drive and loop drive, those are our products, obviously, to do automated validation. Test drive focused on logic validation, and loop drive focused on the physical I/O and the wiring. So we combine those two together to get a full end-to-end test. IEC 61511 for safety instrument systems allows you to do segmented testing. So you can test the logic, you can test the wiring, and the end devices, combine those together, and then get a full end-to-end test. And that's how most owner operators are moving, because it's a lot faster. Allows you to pull segments out of like a turnaround and do it a lot faster.
Also saves time in the turnaround, right?
Time in the turnaround is the big financial savings. Then there's a lot of quality benefits of doing segmented testing as well. So you do a much more thorough test when you're not doing it under pressure while you're shut down, and everybody's waiting for you to finish.
That's your first presentation.
That's the first one, yeah.
And then how does that relate to the second presentation?
The second one is more generic on AI use in automation workflows. And we provide some case study information. Now, keep in mind, this one's not commercial, so it's focused on the methodology, but it's going to share insights that we have and some case study info about using AI on specific parts of the automation workflow. So taking, for example, cause and effect matrices in various formats and using AI to extract and migrate that data into either a new format or a different application, or we provide a few different case studies of what we were attempting to do.
Could you also use that though and kind of relate that back to the first presentation where you're doing your segmented testing as well? I mean, could you use some of the AI to pull the data out to do that testing?
Absolutely, yeah. So the second presentation is focused on in general, different ways that you can use AI. So extraction of the program, extraction of the design document requirements, that's all possible to varying degrees. And then how do you integrate that in with your existing workflows? The big focus on the second presentation is more on the dangers inherent in using AI.
Cool. What are the dangers?
Well, yeah. So,
are there lots of dangers?
There's a lot of danger, yeah. So AI is awesome, and everyone's talking about how awesome it is, but very few people, I think, are focused on the dangers, especially if you're trying to use it for information on a control or safety system. If you're using AI and you're not using human beings to actually review all the information, the challenge that we see is around validation of the results, because AI is very inconsistent. Typically, you'll do a statistical QC on someone's work. You'll check, 5-10%. If that looks okay, you don't really look deeper. You say, okay, they're doing okay. AI may do fantastic 9 times out of 10, but on the 10th time, it may just completely fail, and you're not sure why. It hallucinated, or it's trying to make you happy, so it will make up information. It'll fill in gaps that it finds, even if you tell it don't fill in gaps, don't make stuff up. A lot of people tell it don't make mistakes. I mean, it still does. So,
well, let me ask a question there.
It's trying to be a people pleaser. Is what you're saying?
Yeah, absolutely.
If you feed a narrative to AI that's written in paragraph form, because some of those are in the industry that are describing functions that are supposed to happen more like in just a word procedure, the reading and understanding of that seems to be pretty good.
That's great. Yeah, that's fantastic.
Like a cause and effect, you have a column of inputs on the left-hand side, you have outputs across the top, and you have dots that connect one input as a relationship to an output.
Right.
I've seen in trying to get AI to read that chart and make that connection through that dot seems to have been a pretty big challenge in some of the testing that I've done.
Absolutely. The challenge is there, it seems, on all real schematic type diagrams. You hit it right with the narrative, understanding the language, reading that, and getting an overall understanding to where you can use the information. It's really, really good. But with schematics, it really struggles, specifically like the larger and more complex they get, whether it's a P&ID, a cause and effect diagram, a PLC logic, function block code, or ladder logic code. If you give it small little pieces, it can typically understand those pretty well. You give it a whole program and it cannot, right?
It can't read through the whole program and then kind of give you a summary of what the program's doing.
Not in one go, right? So you can split it apart in pieces. You can feed it to different agents. You can try to get an overall understanding, but it carries a lot of risk, right? That's
but what you're saying there is if you do that, sometimes it'll just make up like if it doesn't understand a section, it'll just make up what it thinks it's going to do.
That's right, and it's also extremely confident. So unless
it's like this is how it's done.
This is definitely it. And I mean, if you find the error and you point it out, it'll say, "Oh, you're exactly right. Like I messed that up." But before you find it doesn't communicate it that way. Like, "Oh, this may or may not be right," or "Here's the data that I made."
Oh, that's
up.
a big deal. Yeah.
Yes.
Yeah. I was talking to somebody about that the other day, is that I think part of the problem is when it gives answers. A traditional person would look at something, go through it, and then come to you or whoever, right? And be like, hey, man, I looked at this ladder logic or code or whatever. This is what I think it is doing. It won't say that. It'll just say, this is what it's doing.
This is what it's doing. Yeah.
Very confidently.
I think that's a good point. Like with the LLMs, how frequently do they come back and ask you a question?
Oh, they don't.
They don't really do that, do
they? Don't do that.
That is a logical way that we come to an answer by saying, okay, I get part of it, but this is confusing to me. Explain that more.
Yeah.
And
that's what you're talking about, right? It doesn't come back and say, hey, this is confusing to me. It just tries to answer it.
To use an analogy in a completely different industry, right? Like for lawyers, it's very good at doing law, at reading things, understanding, reading different cases. There's been a lot of cases documented where lawyers will use it. It will generate fake case law. If the lawyer doesn't notice or doesn't check it, they'll include it. And you've even got folks getting disbarred because they're including this fake
Fake
case
case
law.
law.
Yeah, and like a judge catches it. But you think about how many of these are not getting caught.
Yeah.
And taking that into our industry, if you're doing part of your workflow with AI and you're not validating what it's producing, then
Oh man, that's bad.
yeah, I mean,
With a lawyer and fake case law, a plant doesn't explode.
no. Yeah,
Right?
exactly.
Yeah. Can't have that.
But bad things can certainly still happen there too.
Oh, I no doubt, but it, I mean, that's what you're dealing with, because primarily what you're dealing with is safety systems, right? For the facilities,
Right, yeah.
right.
So we don't want to cover our
that's
eyes.
like the last line of defense. If something happens, the safety system's supposed to help it shut down safely.
Right.
Correct? Right?
And they're scrutinized different than the control portion of the plant, right?
Yeah, we don't want to cover our eyes and say, well, we can't trust AI, can't get it 100% of the way there. We can't trust all the results, so we just can't even touch it or use it at all. That's not going to get you very far. Everybody is using AI. There are huge efficiency gains. I think it just shifts the conversation towards, all right, how do I use it effectively?
Yeah.
And then how do I validate the results?
The results,
or
yeah.
integrate it in with my normal workflow, have humans involved. Probably it doesn't decrease the need, in our experience, does not decrease the need for subject matter experts. It increases it, right? It just reshifts their focus towards the
it increases the need for the
QA,
subject
QC.
matter expert, is what you're saying.
Exactly,
Yeah.
right. It's taking away maybe some of the grunt work you would typically have a lower level engineer do, but it's increasing the importance of the expert in review of the data, approval of it at every stage along the way.
And so we talked about interpreting a narrative and then interpreting a cause and effect diagram. But I think you also then skipped right into trying to interpret logic. So what type of logic are you feeding the system for the testing you've done?
PLC programs, like safety system programs.
So are you PDFing that thing and feeding it into the AI, or how are you?
Essentially, most AI models are going to expect some sort of image, right? And they're not going to understand the native files. So yeah, you have to turn that into an image it can understand, and then feed it in batches, because you can't feed. It typically can't feed hundreds of pages of complex information and have it processed through.
Yeah, so you primarily done that with ladder logic programming or with function block programming?
We've tried both.
Okay.
Yeah.
Which one is better?
Yeah, same result, ladder logic better.
They're similar. They're both not great. Not great. It does great with narratives, right? And it does okay with cause and effects until they get too complex. Programs, even single sheet programs, moderate complexity, seems to really struggle.
Have you tried with a logic diagram outside of the program, but a Boolean logic diagram? You tried any of that?
Yeah, it's basically the same result as the actual program.
Because the tracing of the lines, like on the PNID, spatially finding that something's similar or similarly placed to something else, it seems to be better at that. But following a line through a drawing and understanding that beginning and end.
Yeah, the
seems to be a
continuity from
challenge.
beginning to end, right? So if you take simplistically all your inputs to a PLC program and you follow them all the way through the logic, and then you arrive at the outputs, you might hit, at least a dozen pages of logic in between. So the indexing of that information, the processing of it all together is really difficult. So the industry, even us, we're using a lot of homegrown tools to read and understand that logic. That's more platform specific. We have not seen like a jump in capability of AI yet. To
When you say platform specific, what do you mean?
Like a specific vendor's controller safety system is going to have a very specific, configuration file format.
Yeah.
And some are more open than others, but system integrators and we create our own tools to work with those files in an efficient way. That still is kind of more efficient than using the AI approach.
Yeah.
A lot of those are like text extraction type programs or text evaluation to go through the program in some sort of text format.
The more open systems will, if not directly program in some sort of text format, will allow you to export out to a text format to allow like bulk export and import and bulk configuration. Some systems are locked down, and that's that's not really an option. You have to do it directly in the vendor software.
Well, when we use the term developer, I guess if you're talking about a business app, a website, an app you might use on a computer, that the person that creates that is often referred to as developer.
Mm-hmm.
But they're doing programming. It's just in a language like a C# or some developer language. In the automation and controls world, I think you're typically sort of referring to a programmer, and they're
Mhm.
logging into a vendor application, a platform like a Rockwell platform or a Schneider platform or a Honeywell platform, and they're programming in a language that's pretty specific
Mhm.
to that vendor,
Mm-hmm.
right? It could be the way they built their function blocks interface. It could be the way they built their ladder logic interface or whatever. And so it's a form of development or programming, but it's very niche, very specific to that. And in the Windows or the business development world, AI, especially like Claude and whatnot, has gotten real popular where you can connect AI to your solution and you can say, hey, I want to have this button to do something, and it will program it for you, and then you can take it and sort of refine it, tweak it, and there you've used a boost from AI.
Mm-hmm.
But in terms of the programming in the control system world, those plugins are they a part of that yet?
So really good, like system integrators, good programmers, as you called it, are usually also good developers, and they will come up with software tools. Maybe not a large enterprise application, but they'll come up with tools that make the portions of their job
Like homegrown tools?
homegrown tools that
Yeah.
make portions of their job more automated. If there's a lot of repetition in any task, right, you can really automate that and save some time and money. So there is crossover there, but there's a limitation on the vendor platforms themselves on what all you can do. Some of them are very locked down, and you can't necessarily develop your own software to automatically build the whole program. Some are very open. I don't know if we
Yeah.
want to get into specifics, but there's some platforms that are very open. You can very easily generate code, import it into the PLC, and just run with that, and maintain it completely outside of the vendor software if you'd like to. There is a push in industry to make all of these things more open and to allow owner operators effectively to kind of pick and choose or swap different hardware, use generic software
That's
on
the
top.
OPA
That's
topic?
exactly right. Yeah.
Okay. Yeah, we did because we went to the ARC forum and OPA was a topic in one of our episodes here. We talked a little bit about that
Okay.
open process automation. And in that, yeah, you're trying to make the control systems less vendor dependent and
Mhm.
more interchangeable. But I guess the question I was kind of going to is right now, if you're doing ladder logic or function block, there are no plugins that people are connecting that you know of to their development studio or to their programming studio to change the way they're doing that work yet, is there?
There are some, but they're all, like I mentioned, the ones I'm aware of are more homegrown solutions that individual integrators are using. These aren't really approved industry tools or
Yeah.
standard workflows for folks.
Okay.
Well, given
Yeah.
your 2 presentations that you got at this conference, what are you excited about?
One, I'm excited. This is the first time we're presenting on these topics in Canada.
Yeah.
So I think there'll be some new owner operators that maybe have not been exposed to the way we've been doing for the last 10 years, doing automated testing for folks here in the U.S. So I am excited about that. And,
Nice.
And then the other, I get frustrated because I see so many people talking about AI,
Mm-hmm.
like it'll do everything for you, but I see very few people talking about the dangers or the practical implications of trying to integrate it in with your workflow. So that's just kind of a passionate topic for me. I'd like to get there and talk
Nice.
to people about and
Try to get that message out there, get the word out.
yeah, and a lot of what we do is focus on making facilities safer, right?
Mhm.
Through automated testing, faster, better testing. But all of that can be bypassed, right? If the program itself or the testing, the documentation is being used. If you're using AI and not properly checking everything,
Mm-hmm.
that's dangerous. So I just at least want the industry to be aware of the dangers and to make sure they're doing things to combat it.
Do you know any other like anybody else out there that's trying to use AI? I mean, are you that's what you're concerned about basically, I guess, is that there's others out there that are trying to use AI for this type of configuration or for this type of analysis?
Yes, everybody's trying to use it, right? So the system integrators, the ones programming these systems by and large, absolutely, they're using
They're using it. They're trying to figure it out.
Yeah, but there's
Yeah.
no, to my knowledge, real good best practice for implementation guidelines
Yeah,
or
yeah, yeah.
standards around it that provide some safeguards, right? Like we've been operating with safeguards in the industry. ISA has a lot of standards, for example,
Yeah.
that help the industry go the right direction. We have conferences and forums, but AI advancement has been so rapid. It takes time to
It
get
takes time to get those standards.
standards developed,
Yeah.
right? So we may be running really fast into a dangerous situation if we don't slow ourselves down.
That's
a
what your
little
main
bit.
concern is.
Mhm, yeah.
Okay. Well, that's good.
Yeah, and you were talking about, we touched on a couple of subjects. One of them, you are using the word validation, which typically to validate, you actually run the program, the PLC program, and run it through all of its scenarios to prove that it does what it was designed to do. So you've
Mhm.
got a document that was engineered that says this is what this system is supposed to do. These are the sequences or the shutdowns or the protections, whatever they are. Does it do all of those things?
Right.
The other side is if I only had the paper, both the paper of the program and the paper of the design,
Hmm.
could I just feed both of those in and say, hey, is this thing designed, is it programmed to do what it would do? That would be more of a check where AI is supposed to interpret both sides of that and give you the answer that it is or is not built correctly.
Yeah.
We don't see anything close to doing that at the moment. We see
No, because
we
you
see
need
advancements in the automated validation because
Yeah.
the proof is in. You're maybe talking about 10,000 little scenarios there inside of that box that have to be tested. So it's kind of hard to say just from a paper perspective, is it perfectly programmed, I guess. Is that right?
Right, because you've got a lot of things you need to check, right? Usually there's an instrument index, there's wiring specifications for the I/O itself, and there's a very large PLC program. There's design documents like cause and effects and narratives with a lot of requirements. Some of those are embedded in notes. So to expect AI to read the whole program, all the design documents, and check for every scenario to find all the potential problems, it's a very difficult task. That's why it takes a lot of effort. We've been focused on that for over a decade on doing that activity. But for example, to find that you've got a 2 out of 3 analog input voter, to find that maybe the bad PV tag for one of the 3 is the wrong tag, or
Mhm.
there's a gate that's inverted that shouldn't be, or something like that. To just analyze it without being able to actually simulate the code and run through the scenarios and say, well, this is definitely wrong. That's very, very difficult to do. That's why we run through factory acceptance testing. We actually have to exercise the code to test how it performs and walk it through different scenarios. That's the standard
Yeah.
in the industry. So we're trying to take it and see if can we supplement the standard in the industry, the standard procedure testing, and get an AI analysis to identify some problems before they reveal themselves in the testing.
In the test.
We're not
Yeah.
looking to replace the testing in our case with AI.
Yeah.
Okay. Okay. Interesting. Well, and you're going to this show too, right?
Yeah, I'll be there. I'm just there to look pretty. He's there to be, he's there to be smart.
Thanks.
That's Calgary, Tuesday, Wednesday, Thursday next
That's
week.
right. Yeah. And
Okay.
my first presentation on automated testing is on Wednesday, and the second one is on Thursday. Like 1 p.m. Yeah.
Yeah.
Okay. Nice. Well, thanks for taking the time to talk about that, and good luck at the conference next week.
Thanks.